problem, we have x minus 5 3 times. We have an x minus 7, and we have x plus 1 twice. On the bottom, we have x minus 5, x minus 7, and x minus 7. So I can cancel an x minus 7. I can cancel, that was a 7. I can cancel an x minus 5. And so for this reason, I've been able to simplify. I use the word cancel, but really, remember, they simplify to 1 mathematically. That means there is a whole at x equals 7, and there is a whole at x equals 5. All right, so when we've talked about wholes and I've showed you examples, I showed you examples like this. All right, and we went, oh, okay, we're able to simplify here, but here we could see that we only had a multiplicity of 1 on top and 1 on the bottom. And so I said, oh, here's an example that we have a whole at x equals 2. Now what's a little bit different about this problem is we can see that there's 3 of these, so the multiplicity of 3 is in the numerator for x minus 5, and we have a multiplicity of 1 in the denominator. So because the numerator is 3, it's larger than the denominator of the bottom, which is 1, we can set that equal to 0, and we'll have a whole. When the degree of the numerator, when they're not equal, check it out, when they're not equal, then we have to look at their multiplicities. When the multiplicity in the numerator is greater than the multiplicity in the denominator for this factor, then we have a whole. So I set it equal to 0, I add 5, and I get x equals 5. X equals 5. That's where the whole is going to occur. Now here, you may say, oh, it's a very similar situation, right? So much easier when all of the degrees are just 1, and that's what we were used to working with. So I'm surprised they went to this level, to be honest with you. But over here, we also have the expression x minus 7 on top and x minus 7 on the bottom. But what's different about this is that the multiplicity in the denominator is greater than the multiplicity in the numerator, and when that occurs, you have a vertical asymptote. So I set it equal to 0, x minus 7 equal to 0, which means x minus 7 is the equation for the vertical asymptote. Let's look at one more of these. This is so much easier when it's in this form, by the way, so much easier. Here, we'd have a vertical asymptote at x equals 4, a whole, because they're exactly the same multiplicity at x equals 2. But let's look at one more example. Let me just make one up. If I did x minus 1 to the 5th, x plus 2, and x minus 3 to the 3rd. On the bottom, I have x minus 1 to the 3rd, x minus 3 to the 5th. Okay, so we're looking at something like this. All right, well, I can see here we have the numerator, the multiplicity on top is greater than the multiplicity on the bottom. So that means I have a whole set it equal to 0 and solve at x equals 1. Oh, there's a little gnat playing around there. Now, in this situation, the multiplicity on the bottom is greater than the multiplicity in the numerator. And so we have a vertical asymptote at x equals 3. Vertical asymptote, and that's the equation. If you could go, please, onto the front of your toolbox and write down that little fun fact, that will be helpful for you.